Hello, my name is Galen Pickett. I've been a member of the faculty of the Physics Department at Cal State Long Beach since 1999, way back last century. And figuring out where it all began for me, I would have to say it was an event that occurred when I was in second grade, so 7 or 8 years old. Sitting in school, I've got a pretty clear picture about physical changes versus chemical changes. So I know that if you mix sugar and water together, the sugar molecules disperse in the water, but they don't really change. I've done enough reading to know that that was the case. And the teacher had the gall to claim in school that if you took a mixture of sugar water and put it on a counter, that the water would leave and the sugar would stay. And this just violated my sense of what was reasonable or right. I had a picture in my mind, I'll call it the uniform fluid theory, that sugar water is a distinct physical state from either sugar or water, and that if the water left, and I knew it would leave because I've seen things dry, I knew about evaporation, when the water left, it would take the sugar with it because of the uniform fluid theory, my theory. And I made this point to the teacher, excuse me, you're absolutely wrong. There's no way that can happen. And she looked at me and said, probably the most insightful thing that you could to a person who's eventually going to become a scientist. Well, why don't you go home and try that? And I was so incensed that I said, well, I will, because I'm right and you're wrong. So I went home, mixed it up, put it on a counter. The next day, no, I can't tell anything's changed. A week later, aha, the level is down, but I don't see any sugar in there. The sugar must have left with the water. 2 weeks go by, 3 weeks go by. And to my amazement, there is this crust at the bottom of this glass. And as I'm poking around on it with a spoon, I get a little chip of it out and, oh my goodness, that's sugar. The sugar is left in the cup. So I still remember with actually a little bit of pain that my beautiful idea, my theory was killed by that observation. It is really hard to let go of an idea once you've made it for yourself. And I learned at that point, in sort of hindsight, that I got enough confidence in my own thought processes to be a successful mathematician or a philosopher. But when I apply my thought processes to the physical world, there is no guarantee that what I think is right. And the arbiter of that has got to be what actually happens. And I can't tell you how many times a beautiful idea of mine has been destroyed by actual circumstances. And it never feels happy. It's never fun. But that is the essence. I mean, that is the lesson that a theoretical physical scientist needs to know. And I think that was really the formative event that set me on this course to generate ideas. I love ideas. I love my own ideas more than anything, but that they've got to stand the test of evidence and experience and what actually happens.